Welcome to GKE Firewall Identity. Welcome everyone. Today, we're going to explore one of the most important aspects of securing your Google Kubernetes Engine workloads: how to properly identify your resources for firewall rules. Think about it. When you create a firewall rule, you need some way to tell Google Cloud, apply this rule to these specific virtual machines or nodes. Using IP addresses is like writing someone's home address on an envelope. If they move, your mail gets lost. That's why Google Cloud has evolved 3 different mechanisms for identifying workloads, each with increasing levels of security and control. We'll explore all 3 today. The core challenge. Let me paint you a picture of why this matters. Imagine you're managing a large Kubernetes cluster with hundreds of nodes. Some run your web servers, others run databases, and still others handle background processing. You need firewall rules that say web servers can talk to databases, but they can't talk to the admin servers. How do you identify which nodes are which? IP addresses change when nodes restart. Names might be auto-generated and meaningless. What you need is metadata, labels and identities that travel with your resources and tell the firewall I am a web server or I am a database node. That's exactly what we're going to learn about today. Network tags, the simple approach. Let's start with the simplest approach: network tags. Think of these like those "Hello, my name is" stickers you get at conferences. You know, the ones where anyone can write anything on them and just stick them on their shirt. Network tags are simply strings of text. You can create a tag, for example, web server or database node, and attach it to your virtual machine instances. Then, the firewall can create rules that apply to all virtual machines with that tag. The beauty is in the simplicity. It's fast, easy, and gets the job done for basic scenarios. The downside? Well, anyone who can edit a virtual machine can create any tag they want. There's no verification, no central control. It's based purely on the honor system. How network tags work. Here is how the magic happens with network tags. You create a VM instance and attach a simple text label, for example web server. Then you create a VPC firewall rule that says allow HTTPS traffic to any resource with the web server tag. The diagram shows this beautifully. It is a direct relationship. The VM has the tag. The firewall rule targets that tag. Simple as that. In GKE, this gets even easier. You apply network tags at the node pool level, so every node created in that pool automatically gets the tags. One command, and all your web server nodes are properly labeled. GKE network tags example. Let me show you exactly how this works in practice with GKE. When you create a node pool, you can specify tags that will be applied to every single node in that pool. The command we're looking at creates a node pool called API server pool, and every node in that pool gets the API server tag automatically. No need to manually tag individual nodes. Google handles it for you. This is perfect for development environments or simple use cases where you need basic network segmentation without heavy security requirements. Service accounts. The corporate ID. Now let's step up our security game with service accounts. If network tags are like name tags at a conference, service accounts are like official corporate ID badges with your photo and department. A service account isn't just a label. It's a real identity in Google Cloud's identity and access management system. You can't just make one up. It has to actually exist, and you need specific permissions to use it. This is where things get interesting from a security perspective. When you run a virtual machine with a service account, you're not just saying I'm a web server. You're saying I'm authenticated as this specific identity, and I can prove it. Service account workflow. The diagram here shows how service accounts work for firewall rules. Your virtual machine does not just have a tag. It runs as a specific identity, for example, API runner SA at project.iam.gserviceaccount.com. The firewall rule can then target that service account directly. This means only virtual machines that are actually authenticated as that specific service account will match the rule. Much more secure than a simple text tag. This is the standard approach for most production workloads. It gives you the perfect balance of security and manageability. GKE Service Account Example. In GKE, every node pool runs with a specific service account. This becomes the primary identity for all nodes in that pool. The command shown here creates a node pool where every node authenticates as secure-app-sa at my-project.iam.gserviceaccount.com. What's powerful about this is that you can then create firewall rules based on verified identities rather than just tags. Your firewall rules become statements like allow traffic between nodes authenticated as the API service account and nodes authenticated as the database service account. This is much more secure than tags because you can't just fake a service account. You either have permission to use it or you don't. Secure tags, the ultimate control. Finally, we reach the pinnacle of security and control, secure tags. If network tags are name stickers and service accounts are corporate IDs, then secure tags are like top secret security clearance badges. Here's what makes them special. They combine the ease of use of tags with the centralized control of enterprise security policies. A security administrator at the organization level defines what tags can exist and who can use them. Developers can't just make up their own tags anymore. They can only use the specific tags they've been granted permission for. This enables true enterprise-grade security policies across your entire Google Cloud organization. Secure tag architecture. This diagram shows the beautiful separation of duties that secure tags enable. At the organization level, a security admin defines the official tags, like env equals prod and env equals dev. They then grant specific teams permission to use those tags, but not to create new ones. When a developer creates a virtual machine, they can attach the env equals prod tag, but only if they've been given permission for that specific tag. The firewall policy can then be written once at the organization level and will apply consistently across all projects, even as different teams deploy their own resources. Real-world secured tags example. Let me walk you through a complete, real-world scenario. We have Maria, who works for the central security team, and David, who's a developer on the web app team. The company has a simple but critical policy. Production web servers should only talk to production databases. Maria needs to enforce this policy organization-wide, while David needs to deploy his web application without constant approvals. Secure tags solve this perfectly through separation of duties. Maria defines the security framework once, and David operates within that framework independently. Maria's setup. Defining the framework. Maria's job is to create the security framework that everyone in the organization will use. She does this work once at the organization level, creating the official security clearance system. First, she creates a tag key called environment. This is like saying, we're going to categorize resources by their environment. Then she defines the only allowed values, prod and dev. This prevents teams from making up their own environment names, like prod but for testing, or almost production. There are exactly two environments, period. Finally, and this is the key, she grants David's team permission to use the environment equals prod tag on their own resources. She's not giving them permission to create tags, just to use this specific one. David's deployment. Using the framework. Weeks later, David needs to deploy a new GKE node pool for production. Because Maria already granted him permission, he can attach the official environment equals prod tag to his resources. Look at the command carefully. David specifies the fully qualified secure tag using the organization ID, the key name, and the value. He cannot use any tag that Maria hasn't given him permission for. If David tries to create a tag like environment equals super production, the command will fail. He can only use the tags he's been authorized for. This is the beauty of centralized control with delegated usage. Automatic policy enforcement. Here's where it all comes together. Maria has already created a global firewall policy with a rule that enforces the company's security requirements. The rule says allow traffic only if both the source and the destination have the environment equals prod tag. This single rule, applied at the organization level, automatically enforces the policy across every project. David doesn't need to think about firewall rules. His production nodes can talk to production databases automatically, but his test nodes cannot access production resources. The policy is enforced transparently by the infrastructure itself. The beautiful result. This final diagram shows the end result of our secure tags implementation. We have David's web app with the tag env equals prod, a test app with the tag env equals dev, and a production database also tagged env equals prod. The firewall policy automatically allows the production web app to access the production database. Both have matching env equals prod tags, but when the test app tries to access the production database, it is blocked because the tags do not match. This happens automatically, without any manual intervention. Maria's security policy is enforced consistently across the entire organization, and David can deploy his applications without worrying about firewall configurations. Making the right choice. So, which approach should you use? It really depends on your organization's security requirements and structure. Network tags are perfect for development environments, quick prototypes, or simple scenarios where security isn't critical. They're fast and easy, but don't offer much control. Service accounts are the sweet spot for most production applications. They provide strong security through verified identities while remaining manageable at the project level. Secure tags are for large enterprises, regulated industries, or any organization that needs to enforce consistent security policies across multiple teams and projects. They offer the highest level of security and centralized control.